Okay, and we are back. So, we're going to talk about assumptions conditions for a confidence interval problem, and then we're going to go into an example. So, assumption conditions are crucial every single time we do a confidence interval. We have to check the conditions. This is to make sure that our confidence interval is actually truly estimating what we want to find out. It also makes sure that a normal model is appropriate, which is still important because we are using a z-score in that calculation. So we do have to know that a normal model is appropriate. So our conditions, fortunately, are pretty much the same as they were for a sampling distribution. There's a teeny tiny little change that just has to do with what we actually know in this situation. So, the first one is, do we have a random or representative sample? Again, that just makes sure that there's no bias, which is important, so that we're estimating what we want to estimate. The second assumption condition is that we have independence between trials. So we check that 10% condition is our sample size less than 10% of our population size. And then our third condition that we check is, do we have a normal model? We check that success failure condition. Does n times p and n times q both come out to greater than or equal to 10? This is the one that's technically slightly different. We don't actually know p, the true proportion, because that's what we're trying to estimate. We only know p hat, the sample proportion, so that's what we're using to check that condition. So technically we're checking, does n times p hat, the sample proportion, and n times q hat both come out to greater than or equal to 10? So let's look at a problem. So we have a May 2000 Gallup poll found that 38% of a random sample of 1,012 adults said that they believe in ghosts. We're going to use that sample proportion to find a 95% confidence interval for the true proportion of adults who believe in ghosts. So we have a sample proportion. That is basically our point estimate, the 38%. But we want to be more confident in our answer, that our answer includes or is truly estimating that true proportion. So we're going to find a confidence interval. So there are 4 steps that we take for a confidence interval calculation. These steps are all important. They all are necessary on a free response question. You have to do all of them. Can't skip any. And don't be lazy. So the first one is that we define the parameter that we're trying to estimate. So we would write out P, and this is in words, P equals the proportion of all adults who believe in ghosts, the proportion of all Nightingale students who like quesadillas. I don't know. So we're defining whatever it is we're trying to estimate. That's our first step. Second step is we check the assumptions and conditions. Our third step is we use that formula that we did the beginning of the lesson that we did during class to calculate the interval. And then our fourth step is that we interpret the interval. If we were asked to, and it's usually like in a different part, like a part B, then we would maybe have to interpret the confidence level as well. So back to our ghost problem. So our first step is to define the parameter that we are trying to estimate. So we are trying to estimate the true proportion of adults who believe in ghosts. So I'm going to define P equals the proportion of all adults who believe in ghosts. When we say true, true basically means for the entire population. So we could say the true proportion of adults who believe in ghosts, or we could say a proportion of all adults who believe in ghosts, as long as we're somehow conveying that this is for the entire population. Second step, we're going to check our conditions. So our first condition is, do we have a random or representative sample? And we were told that in this case. If we were not told that, we could potentially assume it. And if it's clearly not a random sample, we could say something like, we assume this sample is representative of our population. Second step or condition is to check for independence between trials. So that is the 10% rule. So I would have to assume that 1,012, which is our sample size, is less than 10% of our entire population, which is all adults. So 1,012 less than 10% of all adults is probably true. That would mean like 10,120 adults or more, which I think is reasonable. And then our third condition is to check, does n times p hat and n times q hat come out to greater than or equal to 10? So n is 1,012. Our p hat, our sample proportion that we were given, is 38%. So 1,012 times 0.38 is 384.56. And then n times q hat, which be 1 minus p hat. 1,012 times 0.62 is 627. Both of those are greater than 10, so a normal model is okay, which again means that it's okay for us to use that z-score to calculate our interval. So our next step is to actually calculate the interval. So again, our formula for an interval is we do the statistic plus minus, we have a critical value, that's that z star that comes from our confidence level, and then we multiply that times the standard deviation of the statistic, so square root of p times 1 minus p over n. Those two things multiply, z star times the standard deviation is called the margin of error. So our formula would look something like this, right? So 0.38 is our sample statistic. So that's p hat. That is our sample statistic. Plus minus, we wanted a 95% confidence interval. Our z star for 95% is 1.96. By the way, 95% is the most common confidence level that you are asked for. So if you're going to memorize any z stars, memorize that one. So 1.96, and then our standard deviation formula for a proportion is square root of p, or p hat, so 0.38 times 1 minus p, 0.62 divided by 1,012. Do that math. You can do it one step at a time. If you're really good, you can try to put the whole thing in your calculator at once. I like to do it one step at a time, but then in my calculator, don't like round in between, if that makes sense. So like if I do the square root part first, I can do square root 0.38 times 0.62 divided by 1,012. And then just like don't clear that out, right? So then my next step would be, so that's the 0.0153. That's the square root part. And then I'm going to multiply that times 196. So I still have that in my calculator. I'm just going to do times 1.96. So it's using that last answer, which is 0.0299. And now I'm going to do the adding and subtracting. So I'm going to do 0.38 plus that number and 0.38 minus that number. So I can do 0.38 minus. I'm going to go up there, scroll up to it, push enter, and then 0.38 plus that number. Scroll up to it, enter, enter. So then I get my interval, which is 0.3501 to 0.4099. So about 35% to about 41% is my estimate, my confidence interval. And then my last step is to interpret that interval. We always interpret the interval, basically just saying, what does that interval tell us? And then if we were asked to as an extra, we could then interpret the confidence level, which I'll do as well just for practice. So interpret our interval. We're saying that we are 95% confident. So that's an important thing to include. We have to include the confidence level. We also want to make sure and include context. So we're 95% confident that the proportion of all adults who believe in ghosts. So make sure you're including context with the problem. And then we include the interval itself is between 0.3501 and 0.4099. I said it a tiny bit differently on this screen just because we don't have to always use the same words. So I could say we're 95% confident that somewhere between 35% and 41% of all adults believe in ghosts. Saying the same thing in a different way, as long as you're including the confidence level, context, and then the interval itself. It doesn't necessarily matter what order you put the words in. But that is how we interpret it. If we were asked as an extra, like a part B, to interpret the confidence level, that's where we would say, if I did this many, many times, if I took many samples of the same size in the same way, about 95% of the confidence intervals that I calculate from all of those samples would include the true proportion of adults who believe in ghosts. Okay, so notice when I'm interpreting the level that I don't actually mention any one specific interval. That's not the point of that interpretation. That point of that interpretation is to explain what it means to be 95% confident. Okay, so that is our example. So that is it for this lesson. See you guys next time.